So x squared plus 4x plus 3 is one of the functions we did. It's the second one. And we found the factored form to be x plus 3 times x plus 1. And then the solutions were x equals -3, comma, -1. Go ahead and pause the video and answer the question, what information about my graph do the factored form and solutions reveal? All right, so after looking at the graph, hopefully you realize that what they reveal are these 2 points right here. Okay, and what those points are my x-intercepts. So the graph, or not the graph, the factored form and solutions reveal the x-intercepts of my graph. And remember, x-intercepts, okay, they happen when y equals 0. So they give me the ordered pair of -3, comma 0, and they give me the other ordered pair of -1, comma 0. Notice those are the x values there are the same x values as my solution. So by getting the factored form and then using that factored form to find the solution, I'm actually finding the values of my x-intercepts. So what we're going to do a little bit later is we're going to actually sketch the graph. So it's important to remember that the solution is how I get my x-intercepts. Now what we're going to look at on the next slide is, well, how do I know if my parabola, which that's the U shape, that's what we call it, it's called a parabola, how do I know if that's opening up or not? Well, go ahead, pause the video, and change the values of A, B, and C, and see which one is going to change how my graph opens up. All right, so after playing around with the sliders, you should notice that if I change C, well, all that happens is my graph moves up and down. If I change B, right, if I change B, it's just going to move my graph right and left. Now, don't get so caught up on exactly how each one affects it. The big idea, like I said, is we want to know which one changes how it opens up and down. And you should have realized that it's the A value that changes whether it opens up or down, which again is consistent with all the transformations that we've looked at before, right? When A is negative, it reflects over the x-axis, so my graph opens down. So as long as A is positive, right? So as long as A is a positive 1, or any positive number, my graph is always going to be opening up. It's only when that value out in front of the x squared is negative that it opens down. And the good news is what we're going to be looking at in this lesson is when A is always positive. So that's how we know that the parabola is always going to open up, is because for this lesson, A is always going to be positive. So let's go ahead and talk about a couple more words that are connected with the sketching and with these quadratic equations. And those two vocab words are zeros and roots. So we're looking at the same function, x squared plus 4x plus 3. So the value of x, where f of x, so the function, is equal to 0, is called a 0 or root of f. Okay, it's called a 0 or root of f, which makes sense, right? If it's setting equal to 0, it's going to be called a 0. We're going to spend some more time later this month, in the next couple of weeks, talking about roots. But know that 0 and roots, okay, they have the same definition. They have the same meaning. So if it asks you to find the roots, it's really just asking you to find the zeros. Now, the cool thing is, we don't actually have to learn any new math to find the zeros or the roots. Well, why is that? Well, let's go ahead and take a look at this function. And it's telling me that the values of x, where the function equals 0, is called the 0 of the roots. So let's go ahead and replace f of x with 0 like it says. And hold up, I have 0 equals x squared plus 4x plus 3. That should look familiar, because what we looked at in the warm-up was x squared plus 4x plus 3 equals 0. And it actually doesn't matter where the equals 0 comes in the function, whether it comes in the front or the back, it's the same thing. So you have to now find the values of x. Well, like I said, we did that in the warm-up. It's just a matter of getting the factored form and finding the solutions. So even though we're now adding in these new words of zero and root, we're not adding any new math to our repertoire. We already know how to calculate zeros and roots. How do we do that? Well, we get factored form. We set the factors equal to 0. We solve each for x. So that's the neat part about this new vocab words that we're adding in. No new math, just some new words. Again, easy to remember because the 0 happens when we set the function equal to 0, and then root is just going to follow the same thing as 0. Well, so we would say that the zeros and the roots for this are going to be -3 and -1, right? If you wanted to go through the process again, you can, but notice it's the same as the solutions, right? So like I said, no new math. We're just solving then for x, and whatever we get as the solutions, -3, -1, those are the zeros or the roots. So we now have all these different words kind of thrown in there, these different forms for answers and different pieces of information. Let's make sure we're on this. Let's make sure we understand how they're all connected. All right, so we're going to have 3 different groups, and there's going to be the 3 different answers, and then we're going to use the vocab words to match up to what the answers would look like. So go ahead and pause the video and try it on your own. Check back in with the answer. All right, so if we look at the first one right here of -3, 0 and -1, 0. These are 2 ordered pairs. And what do we notice? We notice that the y value is 0, and like we looked at on this slide, that happens at my x-intercepts. So this set of points right here would be my x-intercept for the function. And there are actually no other vocab words that are going to fit there. That has nothing to do with, while the values are similar to the zeros, that's not the answer. The answer for the zeros, remember, are my solutions. So this -3, -1. And so like I said, that's the same thing as the solutions. Remember, zeros are the same thing as my roots. So 3 different possible questions you could be asked, one same answer. So if it asks you for the solutions and then it asks you for the zeros, you just write the same thing. X equals -1, x equals -3. And then lastly, this last piece is factored form. Common mistake is people are mixing up x-intercepts and factored form. Notice the difference. Factored form is an equation, right? F of x equals. Factored form, right? Factors multiply together to give us a bigger whole, right? 6 times 2 are factors, and when I multiply them together, I get 12. Well, x plus 3 times x plus 1, when I multiply them together, is how I end up back in my quadratic equation of x squared plus 4x plus 3. So factored form is different than the x-intercept. X-intercepts are 2 ordered pairs. Ordered pairs are not factors. So that's the difference between these 2. So now that we kind of got our vocab, we understand how the solutions connect to the graph, we understand how the parabola opens up. Let's actually sketch a graph. And we're going to sketch the other problem from the warm-up of x squared plus 4x minus 12. That way we already have the factored form and we already have the solutions. So we know that I'm going to have an ordered pair at -6, 0 and a point at 2, 0, because I have my solutions, which give me my x-intercepts at -6, 0 and 2, 0. Now, I know that because my a value is going to be positive, I know my graph is going to open up, so it's going to be something like this. Well, that's not really a great sketch of what the function is going to look like. So what we're going to do is we're just going to choose a couple more points that are going to fall in the parabola, and we're going to use it to complete the sketch. The points you choose are completely up to you. Okay, you're just going to choose some values for x that you want to use. I always like to try to use the point that's right in between my two x-intercepts. So that's going to be -2. And now I just need to figure out what's the value of my function when x is -2. Well, remember, -2 is an input value, meaning I'm going to be putting it in for the x value of my function. So I'm going to go with -2. Getting these parentheses out of here. Here we go. -2 squared plus 4 times -2 minus 12. So when x is -2, my y value, that should be a 6, that should be a y, but my y value is -16. Well, now I have an ordered pair. I'm going to plot it on my graph. -2, 16. Let's go back to the blue color. So, I mean, I could sketch it with that, but let's go ahead and just find a couple more points that are going to fall on my graph. Completely up to you. You can choose any of the points. I'm going to choose a couple more points that fall in between my two intercepts just to give me that bottom curve. So let's go with -4 and 1. Well, same process, right? If x is -4, I need to know what the y value is. How do I get the y value? Well, I'm just going to put x equals -4 into my function. Put it into my function. And what do I get? I get -12, which means my output, or my y value, is -12. So now I have the ordered pair -4, -12. So again, I'm going to go to my graph now. I can plot the point. -4, -12. Falls right there. Same process now with x equals 1. Well, if x equals 1, I need to replace all my x's with a 1 now. When I do that, I get -7. So go to my graph. 1, -7. Well, I know it's going to be a U shape. Oh, this is an extra point right here. Don't need that. I know it's going to be a U shape, so I'm just going to trace these points to make the U shape. All right, we already discussed that it opens up because A is positive. And there you have the sketch of the graph. Again, we knew my x-intercepts from my solutions. We knew it was going to open up. We just had to find a couple more points to help us make our sketch.